My name is Vahid Foroutan. I'm a PhD student at University of Illinois at Chicago. We present a new efficient control framework for controlling groups of heterogeneous stress-engineered MEMS microrobots for accomplishing microassembly. The objective is to maximize the number of controllable microrobots in the system while keeping the number of external global signals as low as possible. We propose a theoretical control strategy that could complete multiple shapes microassembly from arbitrary initial configuration where all the control primitives can be accompanied with a constant number of control pulses of the power delivery waveform. We focus on microrobotic system that can be modeled as nonholonomic unicycle. We validate our control policy with hardware experiments for implementing planar assembly using multiple macroscale robots with direct drive wheels. The proposed control theory is based on design-induced physical heterogeneity in an obstacle-free environment. The size of the programming waveform does not grow with the population size. And finally, the assembly can be efficiently nucleated with an arbitrary number of seed shapes. The following videos show our experimental results. Thank you. The process of assembling the target goal shape starts with maneuvering two robots from arbitrary configuration to form the seed shape, while others confined to the circular trajectories. Following the assembly of the seed shape from arbitrary initial configuration of the first two robots are maneuvered in parallel, progressively assembling the target shape. The position of the robots were recorded using a digital video camera. The control waveform pulses for the control primitives were broadcast using XB wire antenna from a local PC. Because at each iteration of the assembly process, two robots are controlled, creating multiple seed shape is efficient. Hence, the system is capable of creating multiple shapes assembly in a different region.